So welcome everyone, I'm Aled Greenhalgh. I'm a solution architect at Árpád Digital. I'm going to talk about today is my work at the moment helping NHS England to operationalize genome sequencing, genome and whole genome and non-whole genome sequencing within the English NHS, essentially making genome sequencing available as a test like any other kind of pathology test to patients. So our start point is about five years ago with the 100,000 Genome Project, which is primarily a research project. We took 100,000 genomes, obviously, but only from 85,000 patients. Well, what's that about? Because we're looking mostly at the two cohorts we're interested in was rare disease and cancer. When we sequence a cancer patient, we take a sequence of their germline, their sort of normal inherited genome, and the somatic genome, which is essentially the mutation that the tumour carries. So we take two there. Similarly, when we're sequencing a rare disease case, we'll sequence generally a trio, so both the patient, the proband, and the both mother and father if they're available, potentially other family members as well. So as I say, primarily a research project, but out of it did come a lot of kind of individual patient impact. So in about 50% of cancer cases, we were able to identify where a particular treatment, a particular drug, chemotherapy treatment would offer best treatment. Similarly, in rare, between 1 in 4 and 1 in 5 rare disease patients were able to find some actionable findings. So a research project built up a load of data, a load of knowledge, all stored in some knowledge bases. We built up a bioinformatics pipeline. We built up a network of labs. What to do with it now at the end of as we come towards the end of that? Well, to push it out into service as a normal medical service. So we've stood up this a network of 7 regional labs. We've stood up a test directory. Within our health service, we've always struggled to have a single coherent test directory of just pathology messaging. Sorry, just pathology test types. So again, learning from that, we've consulted all of the genetic tests that we will make available in the English service into a single test directory. Unfortunately, right now it's separate. It's held separately from the wider pathology catalogue. Provision of whole genome sequencing along with our sort of delivery partners, Genomics England, but whole genome sequencing only takes up about 5% of genetic testing and genome sequencing. We're also doing very specific panels, and whole exome sequencing was just an element of the genome responsible for proteins. And kind of reconfigured that kind of lab stuff. The important thing is we've essentially taken all that infrastructure, lab and informatics infrastructure, and kind of put a wrap around it to make it a real thing and available within the NHS. So we've not wholly reconfigured, for example, the bioinformatics pipeline. So where do standards come in? Well, first of all, as I say, it's a research project. And the nice thing about a research project is you don't need to worry about kind of interoperability and standards because it'll all be over soon. It's just research. Unfortunately, we've kind of taken some of that legacy and in bringing that into the kind of international service. We now have to think about how we provide that wrap. And we're hoping to use, well, we've been using FHIR to date to do that. In the wider kind of standard space, a lot of the bioinformatics stuff has come from the GA4GH, Global Alliance for Genomics and Care and Health. A lot of that is from a kind of research background. A lot of that produces tools, standard tools, and kind of tool sets. Not necessarily kind of de jure standards like some of these others, but it's stuff that is generally worked and accepted by the scientific and bioinformatics community. Again, we're now having to kind of retrofit that into the wider kind of test ordering and result provision kind of infrastructure for the wider health service. Again, our health service is kind of replete with archaic standards. There's loads of EDIFAT there. There's loads of HL7v2 there. I'm aware that in FHIR there's always been a certain kind of tension maybe with open air. So there were some open air artifacts defined for the genomic data structures. We're only defining FHIR standards right now for the messaging and interoperability. But the point is we've concentrated on taking that existing service and defining messaging and standards for the ordering and the provision of results. So we're not delving deep into the kind of complicated and admittedly really interesting stuff around how we might represent alleles and whatever else as kind of genomic artifacts within FHIR. What we're actually doing right now is just doing the relatively simple stuff around how do we order a genetic test and how do we provide the results back to the clinician that ordered them. I'm going to go into some reasons why that's a little bit tricky anyway. Partly helped by the kind of rather fragmented pathology and kind of a hospital order comm systems that we have anyway. So what we're aiming to do is use the same kind of pathology pathways, the same ordering systems to order genetic tests, genomic sequencing, and get results. The key differences, and the detail here doesn't matter, fortunately, because you can't see it, is that there's an awful lot more clinical data when we request a genetic test than we would normally find in, for example, a blood test. In a blood test, we generally just order a cell count or something like that without really a lot of further clinical information about it. When we're providing, when we're ordering for a sequence, we have to provide a lot more information about, for example, including information in the case of rare disease on the patient's phenotype, what they're kind of externally presenting. Similarly, we had to provide a whole set of information about the family. Again, who within the family has been affected or is unaffected by the specific condition. So, to that end, we're very often ordering not just for the patient, but also for the mother and the father, or potentially the uncle, the aunt, whoever else. So that means that there can be multiple patients included in a test order. So we're now having to work that back with HL7v2 ordering. Well, we can only have one PID segment in a test order message, ORD message. So that's we've had to build a broker there from FHIR, a test order message, which includes information about the whole family, to break that apart into multiple HL7v2 order messages. Same for multiple samples. Generally, we're only interested. Generally, the messaging is set up to provide one sample, one test for the most part, where we're providing samples of both germline and somatic. Then that's difficult. So we've standardized at least to a degree on the HL7v 2.8 for that, and are providing a broker between FHIR and HL7v v2. When has gender and ethnicity ever been simple? Certainly not now, because this has a particular kind of clinical significance in this area. We're aware, I think we're probably all aware of the difference between kind of administrative gender, how someone wishes to be referred to, and so on, and considered, and their karyotypic sex, so the X and Y that they carry, but also the phenotypic gender, so the external presentation, genitalia and so on. It's a very complicated area because, of course, what will often be carried in the patient administration system hides a lot of this detail. Similarly, with ethnicity, ethnicity is kind of scientifically significant in that we compare a whole genome to a kind of baseline of a specific population, which would be informed by that ethnicity. Again, complexity here about the UK's particular approach to FHIR profiling, where we're trying to bring together our English, Welsh, and Scottish national profiles into a single set of profiles. Unfortunately, England, Scotland, and Wales have completely different code lists for ethnicity, and Welsh. So that's understandable. It's things like that become kind of tricky to manage. Family structures. As I say, often in rare disease we have this trio test of father and mother, as well as the kind of affected patient, the proband. We're often also looking at wider family members if you want to provide counselling to the whole family. So we need to find a standardised means of producing a kind of pedigree diagram, as it's termed. So the particular kind of visual representation is fairly standardised. We've used and engaged with the HL7's genomics working group and used their family member history genetics profile, so we can actually provide quite a broad, represent family trees with some kind of complexity. For the most part, it's only these three that the clinicians care about, but we can provide a kind of full family tree. That particular profile provides a whole set of relationships, so you can show maternal aunt and second cousin and whatever. But actually, we found that's kind of unnecessary because the whole entirety of a family tree can be described using only sibling and parent relationships. Using only those two kind of tuples, you can build up a. Well, this is actually any pedigree diagram family tree is a forms a graph, and so we can kind of reason about that in kind of predictable ways. HPO, the human phenotype ontology. So the English National Health Service has kind of gone all in on SNOMED, and we're kind of slowly getting there. We've migrated, in the course of migrating all our GP systems over to SNOMED, for example. So we've bet the farm on SNOMED. Unfortunately, genomics likes the HPO ontology. SNOMED isn't quite there, isn't quite fit for purpose in this area, it's felt. There are a good number, 7,500-ish terms without a direct equivalent in SNOMED. There are, I believe, some attempts to do that mapping, but it doesn't exist right now. It works on a faster release cycle, so I think HPO is released every couple of months, whereas SNOMED is on a 6-monthly release cycle. But in terms of its structure, as you can kind of see here for this particular term, it's quite similar to SNOMED CT in some ways, in that it's polyhierarchical, it's a fully featured ontology, and it's pretty blooming complex and pretty big. So in a sense, we're kind of inheriting all the that kind of complexity of SNOMED, but trying to force this kind of new-ish, new to the NHS terminology into that. We're using we intend to use the CSIRO onto server terminology server to represent this in a kind of FHIR standard way alongside SNOMED, and that offers a lot of the kind of tools that we already use in SNOMED, like subsetting. One of the difficulties we found is to provide kind of scientific or clinical validation of our output. So we've done a lot of profiling, done a lot of design work. But because of a lack of kind of a cohesive body of clinicians to sign off this is correct or otherwise, that's been difficult. Because in this area, I don't know if it's because it's a relatively newish science or if it's just in the nature of clinicians and scientists, because we have a split between clinicians and scientists, and we have these various strands.
So welcome everyone to implementing and extending Firecast. My name is Árpád Metzing. I'm from Hungary, working as a software architect. My colleagues, who are also sitting in the audience, helped me prepare this presentation, so credit goes to them as well. Before we go into implementing and extending Firecast, I would like to give you a very brief overview of what we want to achieve from a user's or from a clinical perspective. Basically, we want to reuse or use Firecast for what we call near real-time clinical context and content sharing. That sounds a bit cryptic, I guess, so let's go into a little more detail. I was not actually authorized to name any products here, but at least I can name some companies. So we want to integrate three major systems: an EMR system. Let me check. So the EMR system, a reading application, and a reporting application. The EMR system is coming from Cerner. The reading application is coming from Siemens Healthineers, and the reporting application is coming from Nuance. So basically, we want to provide a seamless integration of these three systems so that the user, when sitting in front of this system, is basically having the impression that they are acting as one system. So they don't have to manually transfer data from one to the other. What they are doing is doing the reading, performing measurements, creating clinical findings, and they obviously want these clinical findings and these measurements to appear in the report somehow automatically. This is what we call sharing clinical findings from the reading application to the reporting application. On the other hand, they might want to dictate or update some of those findings or those clinical measurements in the reporting application, and maybe they want this information to flow back to the reading application. So this is the update clinical findings, the arrow on the bottom. And obviously, it is very convenient for the user if the selection between those systems is also synchronized. So if the user is dealing with maybe multiple findings and he or she is clicking on one of them, they want that to be in focus on the other system as well. So this is what we want to achieve with Firecast. Okay. So a little bit history of why we chose Firecast and what was before we started using Firecast. This collaboration between the three players started sometime around 2017. It was, to be honest, before my time, so I don't know all the historic details. I joined this collaboration a bit later. The first proprietary solution was released in 2018, so basically last year. It was a completely proprietary context synchronization solution. So nothing standards-based, no Firecast involved at all. There were some FHIR-like resources involved, but the complete system was, beside that, proprietary. It was really good to get some market experience. with the solution, but it was not really future-proof and standards compliant from that point of view. So we decided, after some major discussions, to migrate to Firecast instead. And why? Because according to Firecast specification and their website, Firecast is modern, simple application context synchronization. So that sounds really catchy, right? So everyone wants to migrate immediately. Probably not yet, but I will tell you why not yet in a few minutes. Who is familiar with Firecast from the audience? Can you just please raise your hands? Okay, then I need to show this. Okay. So just a very, very brief overview of what Firecast is and how it works. This is a very high-level architectural diagram. In the middle of everything is a so-called Firecast hub, which is basically a message broker receiving updates from the applications or the clients of this Firecast hub and dispatching those messages to the other clients or the other participants in this Firecast session. If we look at our example, the reading application sends updates of measurements and findings and posts it to this Firecast hub, which then is propagated to the reporting application. This is what I wrote here, receives updates of measurements and findings from the Firecast hub. And of course, the channel works the other way around as well. So the reporting application is capable of sending updates of reporting content back to the Firecast hub, and the Firecast hub dispatches this message back to the reading application. So it's a very simple messaging architecture. Actually, nothing new there. Okay. So that sounds really cool, and Firecast seems to solve all those problems. But, and there are two huge buts in this story. First of all, Firecast is a very much evolving specification, so it's not finalized yet. There is an STU1, but it is changing basically on a monthly basis. And so that's but number one. But number two is that also the STU1 leaves a lot of room for interpretation. So for the developers, it is not sufficiently detailed to be implemented as it is currently. So how do we take such a standard or specification in such a big collaboration with three really big players, and how do we continue, and how do we actually get anything to market? We started the collaboration by having loads of online discussions and having loads of meeting minutes in emails. Now, I guess everybody can imagine what this resulted in. Basically, email hell. I guess we all know that. So we soon realized that this is not going to be the efficient way of communication. Then we somehow found a way to share a Word document to which everybody could have posted their own questions, open points, and so on. Now, this Word document turned into 40 pages under 2 or 3 weeks with completely unstructured content. So we always say, ironically, that we are in the business of solving structured reporting and structured data exchange, but we have no internal structure for our documents, so that's kind of ironic. And this ended up in basically the same hell. And after a couple of weeks in hell, we realized that actually the Firecast specification is written in Markdown and it's open source on GitHub. So what we decided to do was we forked this GitHub repo, created our own repository based on a fork, and all the players in this collaboration were given the rights to contribute to this GitHub repository. And so we were now dealing with the same tools as we do with daily development. So we have history, we have diffs between files, and we have a very clean way of adding our proposals, our extension proposals, in the format and in the structure in which the current specification expects it. So any kind of changes or proposals are expected to be added here on our own GitHub repo. Obviously, our goal is to eventually get all the changes back to the official standards, so we don't want to have a forked version forever. But until we clarify all those open points and until we come to an agreement, this is the way how we communicate and collaborate between these three players. Okay. Sometimes it's working, sometimes not. Okay, so so far so good. We forked the repo. We have a cool piece of documentation. Development can start, right? That's what everybody would assume in this situation. Obviously, there's again a but. And the but is that developers started working, started reading this this forked repository and its contents. And then a week later, we said, okay, in the last discussion, it came up that there is now issue number 253 and 247 on GitHub. Please also take that into consideration next week. I just received this new PDF regarding a new proposal extension to the standard. Please also take that into consideration next week. Okay, here's this chat going on in Zulip. There's also some very important information in there. Please also take that into consideration. And at the end of the third sprint of development, developers' heads kind of exploded. So they said, this is crazy. I am not able to follow anymore what's going on. This is where we are more or less currently. And we did a really big retrospective with the development teams. And we basically decided that this cannot go on anymore. So we need some rules on how we can actually implement such an evolving and such a quickly changing specification. So basically, we came up with three very simple rules. First one, always have a single source of truth as a basis for implementation. So no multiple sources of truth, no different GitHub issues, no different Zulip chats and so on. Instead, have one document. So we have to very much keep to this principle. Second one, a single source of truth shall not change during a sprint, because this is what actually kills the developers if they have to keep always changing what they have committed to for a sprint. And the third one, I have to read this because it's a long sentence. So any inconsistencies or holes in the specification shall be collected during a sprint or an iteration and shall be submitted as feedback to the specification latest at the end of the sprint. Because otherwise, we start to diverge very much from the official specification or official recommendation. And in this case, it will be harder to merge the changes back eventually. This is the current state. We have these agreements, and hopefully in a couple of months, I will be able to tell you that this is working better or whether it's not working at all. That's basically it from implementing and extending Firecast. And if you have any questions, then please go ahead. If not, then thank you very much.